All right, first of all, thank you to Kieran, Liz, and Ryman for putting this all together and giving me the opportunity to present some of my first PhD results, actually. Yeah, the topic that I'm going to be talking about is technology transfer and local innovation in the Thai wastewater treatment industry. So just to give a little bit of background, in many low and middle income countries, there have been significant increases in demands for resources, so water, energy, and food. And in some producing regions, this has led to environmental stress. So now there are some technologies which can help alleviate some of this environmental stress, but most of the inventive activity for these technologies is currently taking place in high income countries. So the successful and rapid widespread diffusion of these technologies in low and middle income countries must involve some form of technology transfer. And by technology transfer, I don't just mean the transfer of technological equipment, but I also mean the transfer of the capabilities necessary to use, produce, and also develop technology locally. So much for context. To go into some more detail about this last point, I'm using a theoretical framework by Martin Bell and David Ockwell, who work at SPRU, actually, at the University of Sussex, very influential scholars. They distinguish between three different components of technology transfer. So flow type A consists of capital goods, services, and designs. So these are the artifacts, if you will. Then flow type B is skills and know-how for operation and maintenance. Together, flow type A and B lead to the development of production capacity at the technology receiving firm or country. Flow type C, on the other hand, consists of the knowledge and expertise behind technology, and transfers of such knowledge leads to the accumulation of so-called technological capabilities. And anybody who is serious about international technology transfer wants this to become transferred to low and middle income countries. And these technological capabilities include the capacity to adapt technology to local needs, to replicate it, to enhance it, and eventually also to create new products. And that then gives local companies a competitive advantage and is important in terms of generating economic growth, green economic growth in low and middle income countries. It's a very simple theoretical framework, but it's useful in terms of thinking about technology transfers. All right, so what did I do? I conducted a case study of wastewater treatment technology using AD in Thailand's agricultural and agro-processing industries. For this, I used empirical evidence from clean development mechanism projects. And then I tried to determine the organizational arrangements which have been used in individual projects to supply AD reactors. So I included a list of the types of arrangements that I focus on here. So trade is one, foreign direct investment, joint ventures, technology licensing, technology imitation, joint research and development programs, and local innovation. And by determining which of these arrangement types has been used in individual projects and how often they have been used, I develop an indicator for the quality of technology transfer that has likely occurred on the ground. So compare, for example, trade to joint research and development programs. In trade, you usually have international movements of capital goods, and then maybe a week-long workshop where the technology supplier teaches locals how to operate and maintain technology. On the other hand, in a joint research and development program, you have very close interactions between local and foreign personnel. So it's much more likely that the people-embodied knowledge upon which the development of technological capabilities relies becomes transferred. All right. And I determined the different organizational arrangements using these four factors. So here on the left, you have the different organizational arrangement types that I just listed. And then in the top, you have different factors that I looked at. So I looked at the location of the company in charge of the detailed design and engineering of the reactor design at the project site. Thank you. I looked at where this company is owned, where the technology is owned that is used in a project, and where the technology comes from, essentially. And then I checked whether these factors took place inside of Thailand or outside of Thailand. And shared means that the factor has been shared between a Thai and a foreign company, and NA here means non-applicable. In terms of technology ownership, this just means that the particular reactor design was not protected by a patent. Okay, so what do the results look like? So there are a total of 81 CDM projects in the Thai wastewater industry. And in these 81 projects, there are 129 organizational arrangements. There are more arrangements than projects, because some projects involve several project locations, and some project locations involve several reactor designs. So I looked at each location and each reactor design individually to analyze the full breadth of interactions between Thai and foreign companies. All right, so looking at the distribution of the organizational arrangements here on the right, you can see that Thai firms seem to hold quite high levels of technological capabilities. So the imitation category and the local innovation category are the most prevalent. The high incidence of joint research and development initiatives suggests that there's some high-level technology transfer going on between foreign and Thai companies. And then this graph also suggests that there is fairly limited involvement of foreign-based companies. So trade and foreign direct investment are relatively uncommon. And lastly, I haven't found any evidence for licensing agreements or joint ventures. So when looking up this micro-level information on all these projects, I found some additional insights about these companies, which I thought would be worth sharing here. So first of all, you've seen that the imitation category was quite prevalent. And that actually groups together many different types of processes that go on in terms of technology transfer. So I found some companies who acquire large parts of their technological expertise by hiring people who had previously worked at foreign-based companies. And through that, they internalize technological expertise, which contributes to their ability to offer their own reactor designs. There are also some companies which learned by using. So this essentially means that some companies were mainly active, or were only active in the operation and maintenance of AD reactors for a long time. And through that, they learned about the design, essentially, and eventually they became able to offer their own reactor types. And then there's another interesting point to be made about industry fragmentation. So here, this graph here on the right shows the number of organizations that work with one or multiple wastewater types and one or multiple reactor designs. Thank you. And based on that, you can see that most companies actually specialize in one wastewater type and one reactor type. So this suggests that the market is highly fragmented and that there are many specialized suppliers in the Thai AD market. All right, so what does all of this mean? The framework already made clear that there is a need for more precise definitions for what technology transfer actually means. Simply saying that technology transfer is needed is not enough. One needs to carefully define what that actually means. And there has been some progress made in the recently adopted technology mechanism under the UNFCCC, which is not directly related to water, but seeing that anaerobic digestion reactors are a technology which use water as an input, it is related, definitely related to the focus of my study. And the second point to be made is that the role of organizational arrangements should be considered, and the role they have for technological learning. Now, it's not quite clear to what extent policy that favors one arrangement over another can or should be based on market-based mechanisms, at what level such decisions should be taken, and also how one could incentivize technology suppliers to engage in arrangement types that require them to share their intellectual property assets. But despite all of these unanswered questions, to my knowledge at least, organizational arrangements clearly play a role in what type of knowledge becomes transferred internationally, so they should at least be considered in policy circles. And finally, the last point I made here about industry fragmentation suggests that there are certain technology characteristics that affect the transferability of technology. So in the case of anaerobic digestion reactor, we've seen that there are many specialized suppliers on the ground, which potentially opens up space for local suppliers to provide systems and generate economic growth in the country. So that's definitely an interesting area for future research. Thank you.